evening, students. Today I want to explain in coordination compounds regarding isomerism. In case of isomerism, better we have to understood. I will explain some 2-3 questions. Definitely, easily you can understand this isomerism. Now I want to explain. First of all, first question. The total number of structural and stereoisomers of the cobalt tetraammonium dicyanide nitrate. First question is the total number of structural and stereoisomers of the cobalt tetraammonium dicyanide and nitrate. In this complex, we have to, they will give you options. Option A 4, option B 6, option C 8, option D 10. We have to count the number of isomers of the total number of structural and stereoisomers of the cobalt tetraammonium dicyanide nitrate. First of all, we have to. I want to explain about structural and stereoisomerism. What is meant by structural isomerism? Structural isomerism. If you take structural isomerism and also stereoisomerism. I give clearly what is structural isomerism. Structural isomerism means the attachment of the central metal atom to the ligands with different types are there. First one is linkage. Second one is ionization. Third one is ambidentate or flexidentate. These are the different types. To take stereoisomerism, we have to consider geometrical isomerism and we have to take optical isomerism. Optical isomerism. Geometrical means cis-trans, we know. We have to consider these all included all types in this complex. Structural as well as stereoisomerism. In stereoisomerism, we have to take geometrical and optical isomerism. If you take this complex is cobalt tetraammonium dicyanide NO3. This is Ma4B2 type. This is Ma4B2 type. In this Ma4B2 type, if you take, this is the central metal atom in both form, in cis form and trans form. Both are optically inactive. If you take consider, both are having plane of symmetry. That's why it is optically inactive. If you take B trans and A. If A are considered as ammonia, B is considered as cyanide. This is having clearly plane of symmetry. This is optically inactive. If you take transform, B, A. This is also A. This is also having plane of symmetry. That's why this is a cis form. This is also having plane of symmetry. That's why it does not show any optical isomerism. This is also optically inactive. If we have to eliminate this optical isomerism, because in case of optical isomerism, both cis form and trans forms are optically inactive. That's why this does not show any optical isomerism. we eliminate this one. We have to consider only structural and geometrical isomerism. If you take this cobalt, first of all, this one, if you consider cyanide, both will exist. Cyanide cis and cyanide trans. This is the first one. Both are cis and both are trans. If you exchange this one, second we have to take one of the cyanide is taken exchange. What you have to consider, this is the ionization isomerism. One cyanide here and take nitro NO3 here, then one more cyanide is outside. If you consider this one, this is considered as ionization isomerism. In this case, if you write cyanide and NO3, cyanide and NO3. This is cis, this is trans. 1, 2, 3 and 4. If you take third option, linkage. This is ionization, we exchange. Next we have to consider this one, linkage, different. Nitrogen attached to the central metal. CO, ammonia, tetraammonia, NC, the NO3. In case of attachment of this central metal atom, this is NC will show the two different type isomerism. NC and cis, NC and cis, NC and C trans. Okay, next you have to exchange this one to ionization isomerism. Cobalt, diammonia, tetraammonium, NC, NO3. Next NC. If you take NCNO3, cis, NCNO3, trans. This is the fourth one. Total how many isomerisms? Cis trans. This is total considered as a 1 iso 1. This is 1. Total how many? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 isomers. Okay. In this case, have to consider total 8 isomers. So option C is the correct one. Okay, na? Understood, students? Now one more time I will explain. In this, if you consider this isomerism, the total number of structural and stereoisomers of the cobalt tetraammonium dicyanide NO3 complex. They have here 4 options. Only A is 4, B is 6, C is 8, D 10. Which one option is the correct? First of all, you have to understand this one. What is structural? What is stereoisomers? Structural isomerisms are different types. One is depends upon the ligand attachment to the central metal atom. They will show different types of isomerism. One is linkage, ionization, ambidentate, etc. etc. Next, we have to take stereoisomers. Stereoisomerism is geometrical isomerism and optical isomerism. In geometrical, we consider cis and trans. This complex is the Ma4B2 type. In this complex, both cis form as well as trans form, both are optically inactive. That's why this does not show optical isomerism. How to eliminate. Next, we have to consider only geometrical and structural isomerism. If you take structural and geometry, this complex, if you consider ammonia is 4 is same. This if you cyanide is considered, one is cis form, cis type, another one is trans form. Same. If you exchange cyanide with NOT ionization through ionization isomerism, this is considered as Cn NO3, again considered as cis and trans. If you depends upon attachment to the central metal atom donor, if we donate to the nitrogen, that is considered as NC isocyanide. Two types, one is cis, another one trans. If you take NC and NO3, NC and NO3 also cis and trans. These are the different types. Total 8 isomers. The option C is the correct one. Okay. Thank you.